Okay, so now today we are going to study about how to find work done when force is variable. Okay, how to find work done when force is variable. Okay, so let's suppose a block is constant. Okay, let me write down the question. Let me write down the question. Okay, a block is constraint to move to move along x-axis, along a x-axis. Okay, and under the force F is equal to minus x. Okay, under the force F is equal to minus x. Okay, and find work done. Find work done. Find work done when object move from x is equal to 2 to x is equal to minus 4 meter. Okay, we have to find work done in this scenario. Okay, guys, the best way to solve such type of question is draw the graph. Okay, draw the graph. Then first we draw the graph and then we try to solve out the question. Okay, so let me draw the graph. Okay, because this force is variable and it is quite simple graph. Okay, it quite simple force. Okay, so let's draw the graph. Okay, this is my x-axis, this is my y-axis, this is my x-axis, and the graph will be something like this. Graph will be something like this. Okay, graph will be something like this. Okay, so let's suppose this is 2, this position is 2. Okay, and this position, this position is 4, minus 4. So this is 2 meter and this is minus 4 meter. Okay, guys, if you know about work done, then work done basically is dw is equal to integration of f dot ds. Okay, integration of f dot ds. Okay, and here what is the ds? Ds is basically displacement taking place along x-axis. Okay, along the x-axis. Okay, so can I write f is equal to minus xi? Okay, this is the dot. What is the ds? Ds, if you look at displacement, so ds, let me write down, it will calculate. So ds is equal to displacement is along x-axis, so can I write dxi? Okay, so this will be dxi. So here displacement become minus x dx. Okay, I into I. So and what is the what is the limit? Displacement taking from x is equal to 2 to x is equal to minus 4. So initial position is 2, so from 2 to minus 4. Okay, this is your dw. So what is the W? Here this W is basically work done because it is constant, so it become W is equal to, okay, let me put limit. Okay, when there is no displacement, then work done will be 0 at when initial displacement is 0. So 0 to W, this become minus x square by 2, and this is from 2 to minus 4. Okay, this is minus 4 from 2 to minus 4. So if you look at this carefully, what is the W? W is equal to minus 1 by 2, here x 16 minus 4. Okay, minus, so this work done will be minus 6 joule. Okay, what is the work done? Work done will be minus 6 joule. Okay, so these are the quite simple question, you should do it. Okay, and another question is, when with the help of diagram, with the help of vector, etc. Okay, so let's do it with the help of vector, and that form is also very reliable. Okay, and this is the very fundamental. If you get a force, then try to draw the free body graph. If force is variable, then try to draw the graph. Okay, try to draw that graph. Okay, okay, and otherwise you can use directly this method also. This is just vector representation, you can use it directly. Okay, but first you have to think about how displacement is taking place, etc, etc. So listen here, when object is, this is origin. Let's suppose when object is here, when my object is here, so what is direction of force? Direction of force is in this direction. Okay, force is in this direction. Okay, and displacement is also taking place in along this direction. So from here to here, work done is positive. Okay, because direction of displacement, direction of force is same. Okay, so should I write, I'm not going to consider sign. Okay, I just need magnitude. So x dx from, and and okay, and here you have to think about displacement from 0 to 2. Okay, because I had taken I am not consider sign, I had just added magnitude, I determined sign by myself. Okay, my work done will be positive. Okay, my work done will be, because a force is acting along this direction, displacement taking place along this direction, so work done will be positive. So what is the work done? X square by 2 from 0 to 2, so this will become 2. Okay, now after this, when object is, let's suppose, is somewhere here. Okay, so direction of force will be this, because it's along the positive, but displacement taking place along this direction. So throughout this region, work done is negative. Throughout this region, work done will be negative. So let me do it. Okay, and what is the displacement? Displacement taken from 0 to 4. So minus x, I had just write mod. Okay, I had determined the sign, the work done will be negative, and then force will be more, magnitude of force will be x, and this is displacement. Okay, and displacement is 0 to 4. Displacement taking place 0 to 4. So this is the minus x square by 2, and this is from 0 to 4. If you look at this carefully, it become minus 8. Okay, so work done is equal to minus 8 plus this amount. So minus 8 plus 2 is equal to 6. Okay, minus 6. So whatever method you want to do. Okay, and all are very important method. Okay, you can do it by this vectorial, by this vector method, by this method. Okay, and by this method. Okay,